Previous section, we talked about this equation. And we said it was an equation of a line. Well, equations like this we call linear equations. Linear equations are equations where the exponent, the value of the exponent, is 1. In fact, no higher than 1. Now there are two variables in this equation, but let's start by discussing linear equations of one variable. So suppose you have an equation 3x plus 2 equals 2x minus 2, or rather, let's make this better posed, 2x minus 3. Here we also have a linear equation because the highest exponent is raised on our variable is raised only to the power of 1, and there's only one variable here, so this is linear in one variable. So we can solve this problem using algebra. Let us do that. So I want to get my x's on one side and solve for x. So the way I will do that is, first thing I'm going to do is I'm going to subtract 2. That will cancel with this 2, and if I do that here, I have to do it on the other side. And then let me, over here, subtract off 2x, so that 2x minus 2x cancels over here, and I have to do it also on this side. So minus 2x plus 3x is just x equals, and then I have minus 3, minus 2 is minus 5. So let's see if we made a mistake. So our original equation was 3 times x plus 2 equals 2 times x minus 3. Get rid of that x there because I want to stick in my minus 5 to check. And we see this checks out. Left side equals the right side. So the answer to our equation here is minus 5. Sometimes our linear equations, here's another example, sometimes our linear equations might appear in a form like this. So in order to we want to get our x's on one side and our constants are on the other side, but first we need to get these things up into the denominator. So on the left over here, I'll multiply by 2x minus 2, which means I have to do the same on the right, 2x minus 2. And then on the right, I'm going to multiply by 5x and 5x over here. So essentially we have 5x over 5x, or let's write this out. We have 5x over 5x now times 2x minus 2, which is 1 times 2x minus 2 equals 2x minus 2. And we have 2x minus 2 over 2x minus 2, which is 1. So on this side, the only thing we have left is 5x. So essentially we're down to 5x equals 2x minus 2. Now we're going to solve this the same way we did the top one. 5x minus 2x. So I'm abbreviating the algebra here. So 3x equals minus 2 and x equals, so I'm going to divide both sides by 3, minus 2/3. Let's check it. And I'll leave that to you to check. but we'll write it out here for you so you can check your answer, how you checked it, and it checks out. Let's go back and revisit the equation we had in chapter 1 where it was y equals 2x plus 2. We plotted it and we said this was a line. We saw this was a line, and this is the equation of a line. Well, this is the equation of the line in a form we call the slope-intercept form. And as it turns out, this line crosses the y-axis at 0, 2, and that's the intercept here. It's actually represented in the equation. And this line also has what we call a slope. And the slope of this line, often I'll refer to it as m, they also do that in your book, is equal to 2. And the slope represents what we call a rise over a run. You probably are familiar with that term. And what that means, essentially, is the equation goes up 2 every time it goes over 1. So this is like slope of 2 over 1. And anyways, the slope is also represented in this equation right here in front of the x term. There's a 1 in front of the y term, so this is the slope. And that's why we call this the slope-intercept form of a line. And it's very easy to look at this and figure out how to set your line up because of that. So you just plot your y-intercept, and then with the slope of 2, you go up 2, and then over 1, and that's going to be a point. So 2 plus 2 is 4, and then if we're starting at 0 and we go over 1, that's 1. So that's the point x equals 1, y equals 4. We could go in the opposite direction down here. Now slopes that are uphill are always going to be positive, and slopes that are downhill are always going to be negative. So this line has positive slope, so it's going uphill. So let's look at a general line for a second here and come up with a way to figure out analytically what our slope is. Let's suppose we have a value on our x-axis here. We're going to call it x1. So it's going to be a variable. And we have some, could be any number, x2. So for this x1, there is 1 y1 associated with it. So this is the point x1, y1. And now for this x2, we have the same idea. There's a y2 over here. So this is our point pair, x2, y2. So if we want to figure out the slope in general for a line, then what we need to do is we need to take this distance here as our rise and divide it by this distance here as our run. So now we just got to simply figure out what those distances are. Well, let me get rid of this m. I want some more space over here. Well, the distance from the x-axis up to this y2 is y2, and the distance up to y1, let's do a different color, green I guess, is y1 here. So we're interested in this distance here, so that's just simply y2 minus y1. So that'll be our rise. And then for our run, we can do the same thing in the x direction. So we have this distance is x2, and then this distance is x1. So our run distance is the difference between those two, x2 minus x1. So suppose we have these values for x1, x2, y1, and y2, or the point pair 5, 4, and put this underneath, I guess there's more room, and 10, 9, then our slope, call this our slope m, equals y2 minus y1, 9 minus 4, over x2 minus x1, 10 minus 5, equals 5 over 5 equals 1, slope of 1. So I've gone and plotted those points on a Cartesian axis here, where this is y and this is x. And those 2 points will form this line, and this line has a slope of 1, like we calculated. Now, the question is, where do we cross the y-axis here? Because I want to set up my equation for my line. Y equals the slope times x plus the y-intercept, and I need to have these 2 points. To do that, well, from this information, I know m equals 1, y equals 1 times x plus b equals x plus b. So how do I figure out where I cross this at? Well, what we could do is we could go back and we can look, and we see that I have an equation here for y in terms of x, y is a function of x, and then I notice that I have 2 points already on this. I mean, by definition, that's how we set it up. So what I could do is I could take either of these 2 points, I could sub either of those 2 points into this equation and solve for b, because I'll have 2 values here, and the only thing that I won't know is b, so I can solve for b. That has to be the case. So either of those 2 points will make it valid. So let's choose the easy one, I guess, 4 and 5. So I stick 4 in for y, 5 in for x. So this turns out to be minus 1 equals b. So if you have points, you can always do this. So that means that this point here must be the point 0 minus 1. That's if we did all the math correct. So let's check our results. So our equation now is y equals x minus 1 for our line. Let's substitute in the other point and see how that checks out. And the other point is 10 for x, 9 for y. We get 9 equals 10 minus 1 is 9. It checks. And that's how you'll find, given 2 points, the slope-intercept form for a line.